Very good afternoon. Myself, Dr. Ravi Kumar Poluru, working as Assistant Professor, the Department of Information Technology. Today, we are going to discuss about achieving required quality. So here, mainly in software economics, we have seen that we have the five parameters in that. First one is size, process, personnel, environment, so environment, and the last one is the quality. So these are the five metrics for calculating the estimation of the software cost. So we have seen that how we are going to minimize or reduce the size, and how we are going to improve the process, and what are the metrics for the improve the personal, and what are the automations process which you are using for improving the softwares. Today we are mainly discussing about how we are going to achieve this quality. So what is meant by software quality? Software quality is nothing but how these software applications will meet specified requirements. It means when you're designing any software, the main exact or the end product has to be achieve all the requirements. Then we can say that this software is achieved the quality. How can you justify it is the software is having the high quality? High quality in the sense we are checking the software without any bugs or defects, or we can call as the errors. Then we can say that the software is performing very well. So this software consisting of high quality of software. This software quality is measured based upon software system satisfies, and also the number of users needed, and where we are going to implement this, such as the industry standard and the best practices. So based upon that, we are going to measure the software quality. This software quality is having a multi-dimensional concept, such as functionality, reliability, maintainability, usability, efficiency, portability, and security. So in this diagram, we can see that the software quality is mainly having like the testability. It means when you're testing the software quality, this software have does not have any errors or bugs while you're testing the software. And the usability, so usability is very useful for the checking the software. This has to be maintained, because when you are using the reuse concept, the software can minimize, and also this software can be usable for any different types of the applications. And we need to verify about the efficiency of the software. Okay, and mainly we are going to check that how much the flexibility will be applying for this software. And the portability in the sense, for example, if you're running the same software in Windows, and same when you're using in the different types of the platforms such as Linux or the Mac, the software has to be executed without any errors or slightly modification of the software. So this we can call as the portability. And reliable. So it should not guarantee the information, to transmit the information or to display the information of the software in a reliable manner without any degradation of the performance. Okay. Now how we are checking that here, the software quality will be having various activities and the process, such as requirement analysis, design, coding, testing, and maintenance. So these are the main life cycle phases which we are seeing in the software quality. So here mainly we need to verify about the what is the in detail requirements and the resources which will be useful for the software, and we need accordingly. So we need to use the coding part, so the design architecture part, later, then we need to check that which programming language is very suitable. So based upon that, how many lines we can reduce by using this high programming or higher order programming language. Okay, then in testing, so while you're testing the software, we need to verify what the software has to be executed without any errors or the bugs. After releasing the software, so maintenance is very important. Okay, so here each and every time, like halfly or quarterly or annually, so we need to release the updates. Okay, so that the maintenance is very easy for providing the security. So here we have the different types of the activities for the software quality, such as the software developers, testers, quality assurance professionals. So to develop for the software, they need to maintain the high standard of the quality. Means they need to check the standards of the software while they're designing or writing, developing the software and providing the high quality of the software. For any software quality, mainly they need to check that three C's. So what is mean three C's? Means competencies, completeness, and correctness. So in the software quality, the first one is correctness. Correctness is nothing but the ability of a software to perform its intent functions correctly. It means without any errors or the bugs, the software has to be executed very clearly. And also the correctness is mainly checking the what is the aspect of software quality and make sure this software is meets the requirements and the expectations of the user. So we can define that this is having the more correctness. And what is meant by completeness? Completeness is nothing but degree to which the software applications fulfills. So we need to check that what is the main criteria for applying for this software in a specific software applications, and also the requirements and the performance for that particular function here. The completeness is nothing but here this software has to be meets to the user requirements and the purpose, and it has to perform all the tasks while they're designing the software. Okay, and next the last one is consistency. Consistency is nothing but here how this software application is behave, okay, in a uniform and as well as they are to check that predictable manner in a different types of the platform. Like we can check that this software has to be executed in a Windows or in a Linux, like Mac. So different types of the platforms, this software has to be executed without any getting the errors. Okay, and also this can be implemented in the different types of the platforms and the environment. So consistency is very important for the softwares to provide the reliable and also the different types of the users in a different situations here. Okay, so here how we are going to improve the software quality. First one is test early. So testing is very important for checking the defects in early stages. Okay, during the design phase, so we need to check that what are the bugs in that particular software. Because after releasing the software, if you are going to find out the bugs, it is very difficult. So we need to verify the defects early. And software development teams mainly they are going to check that manual testing for many problems. Here, the companies will be verifying about the different types of the testing like manual as well as the automated testing. So mainly they can have the manual testing and also automated testing. So company mainly they are going to have the look on the automated testing for the non-UA task. Okay, remaining thing they can go for the manual testing for the software development test. So testing is early. It will be mainly reduce the money spent on bug fixes. So after releasing the product of the software, if they are going to find out the bugs, so it is very difficulty, and the cost also will be. For example, if you are going to spend the $1,000 for developing the software, and if you are identifying the defects after releasing the software, then it will be the cost will be 10 times or 100 times will be here. It means $10,000 the cost will be happen here when you're identifying the bugs after releasing the software. So that's why we need to identify the bugs in early stages. And next, we need to implement the cross browser testing. It means we need to check the different types of the browsers for this software. Cross browser testing checks. So it means the software runs in different types of the web browsers, the screen sizes, as well as the mobile applications. Okay, multiple devices and the models coming out in the market. So mainly this cross browser testing is very having the integral part for the every developer. It means we can cut the cost and we can improve the speed and the performance of your products when you're using the cross browsing testing here. So it will be having the scalability and dynamic for the different types of the browsers for testing the tools here. Next one is test on multiple devices. So this software can be uh, test in a multiple device testing. So to get the better decisions regarding the software development and improving the quality here. Whereas we can have the number of devices, screen sizes, and operating system configurations in the market. So that here uh, we can have in the multiple devices such as Windows, Linux, Mac, the two most popular operating system for testing the purpose. For example, if you're taking the web browsers such as Chrome, Safari, Opera, and Firefox. So these mainly nowadays most of the users they are using the Chrome and Firefox. Okay, and Opera, Safari. Safari is mainly used for the where if you require the high configuration of the images. There, this Safari can be very useful for the users. And next one is optimized automation testing. So here, instead of the manual testing, automated testing and the agile methods will be having to improve the software quality. So in the 2021, so World Quality Report having the automation testing tool can save the time. So when you're comparing with manual testing and the automation testing, this automation testing can be save the time and enhance the coverage, minimize the human errors, and improve the testing capability. So with the help of this automation testing, so the performance will be improved and it will be minimize the human intervention and also human errors will be minimized, improve the quality of the software here. So here we have the smoke testing, regression testing, and cross device and cross browser testing and load testing. These are the most popular testing for the automation testing tools, which will be uh, have the more quality, accuracy, efficiency, and it will be improving the performance when you are using the automated testing tools here. Next one is use quality controls from the beginning. So from the beginning, starting onwards. So this control management and quality management, mainly they are going to verify about the testers, how they're going to cooperate with the developers as well as they need to work as a team members. Okay, so it will be very useful to improve the test process and also minimize the maintenance cost with the native testing tools here. So that's why from the starting onwards they need to concentrate on the quality as well as the control management for smooth running to minimize the maintenance cost and improve the test process. Next one is leverage continuous deliver and continuous integrations. So CI and CD is mainly used to integrate the changes and improvements to each and every step of the software development lifecycle. So when you are using this continuous delivery and continuous integration of the softwares, so that it will be improving for each and every stages of the software development lifecycle and have the clear communications. So when you are using the clear communications with the team members, so it will be the software quality will be mainly impacted. It means it will be improved. Why means uh, they're using the consistent KPIs means key performance indicators. So when they're using the key performance indicators through the project, so that they're getting the accurate test reports, helping for communicating with the team members. So here the how the they are going to communicate the team members, means like keeping the review meetings and getting the reports. Based upon the reports, they're checking that what are the key performance indicators, so that it will be have the look on the getting the how much accuracy they're going to generate the reports, and it is very easy way to communicate with the team members. Next one is document your project requirements. So good documentation is very important. So in the starting stage onwards, so they need to develop the design as well as the documentation. If the documentation is very clear and good, so it will be very helpful for the team members. Based upon the documentation, they're going to do the projects, and it will be very easy to understand when they're getting some when they're having the problems. That's why the good documentations will be defining the scope of the project. So based upon this documentation only, the project will be moving from the starting stage to the ending stage, and also having the milestones and the deliverables and technical specifications. So this has to be meet the deadlines and stay on the track here. So the documentation is very important for the team members, and also it will be very useful for the customers' needs, and they're going to verify about the different types of the functional and the non-functional requirements here. So next one is incorporate employee training. So here employee training is very important while they're going to handle the different types of the software projects, and it will be impact for the employees for getting the knowledge here. So here employees can play the role of your end users. So when they're having the good skills on the tools and the technologies and the techniques, so it will be very useful for when they're going to check the latest trends here. So employee training instills an awareness of what to look out for the leading software products. So that's why it is very important that in corporate, so employee training is very important to gain more knowledge on the tools, techniques, and the technologies what they're going to use for the latest trends here. The next one is create a quality management plan. So here the quality management plan, it means it should be a very documented plan here, and it will be view the software quality expectations, and they need to assign the roles and the responsibility, and it also has to be support the project managers and organize the task to ensure that software development matches to the customer requirements and the expectations. There should be a list of the documentations how this software quality expectations and what are the roles and responsibility will be impacted to the customer requirements and the expectations during the software development quality. Improve the quality here. Next one is do formal technical reviews. So review is very important for each and every stage because they need to identify the bugs and also whether the team members are doing the project in a proper manner. So the experts has to be sit and they need to discuss with the team members, and what are the information they are going to done by the team members has to be explained to the stakeholders. So in a formal technical reviews, stakeholder meet and discuss the logical and functional errors. The software program. So these reviews will be having the team of engineers and having the in detail about the reports for the presentations. So here the experts will be mainly first it will be experts will sit with the team members and taking the review. So and writing the in detail about the report. Later they will be sit with the stakeholders and they're going to explain about how much work they have done and how much quality they have improved. So these stakeholders and the experts having some discussions regarding the logical and the functional errors of a software program. Okay. The next one is produce bug report. So a good bug report can make a software testing and improvement highly effective. So that's why in a report they need to generate the what are the software testing and the improvement means in detail about the report they need to generate and have the possible scenarios and have the use cases and describe behavior of the testing. Okay, so that they can check that where the bugs or the failures have been happened expectations. So they need to take the screenshots in the report and list out all the possible solutions and have a bug summary. So it will be very useful for how see uh, how the software will be generating the quality means when it does not having a single bug or the defects in the particular software. Okay, so before releasing to the market, so if they're going to identify the bugs, so they need to verify about the what are the possible ways to minimize the bugs and have the brief summary about the bugs to minimize the software errors, so that they can easily have minimize the cost also. So these are the mainly metrics to improve the software quality, and we have the different types of the improving the cost efficiency. Okay, and here they are taking some quality for the same cost. This in the left side we can see that the quality driver, and we have the conventional process and modern iterative process here. So when you're taking the requirements, if requirements is misunderstanding by the team members and the stakeholders, in conventional process they are discovered late. It means after completion of all the stages, they are going to check that what are the requirements they have misunderstanding. So the cost will be very high here in the conventional process, whereas in the modern iterative process, they are verifying the requirement misunderstanding resolved earlier. So it means each and every, they have the reviews, and they're going to check that what are the problems they are faced, so that they are rectifying very earlier. And development risk. So in the whereas in the conventional process, the risk is very high here, because unknown until late, because they're going to identify the risk after completion of the stages only. So whereas here in the modern iterative process, so in the initial stage only they are going to understood and resolve very quickly here. And commercial components. So in the conventional process, mostly these commercial components are not available. So whereas in the modern iterative process, quality drivers and how the trade-offs must be resolved early in the life cycle. So mainly here, the commercial components are mainly used in the modern iterative process. So whereas in the change management, so late in the life cycle, it means after completion of the stages of the life cycle only, they are going to identify the what are the changes. So not before that, each and every review process. So whereas in the modern iterative process, early in the life cycle, it means it is in a very straightforward, and they're going to minimize this change what changes will be happening. And design errors. So design errors will be identified only after discovered later. Whereas here in the initial stage only they are going to identify the what are the bugs or the errors are identified in the design part here. And next one is automations. So in the conventional process, mainly error-prone manual procedures. They instead of using the automations, they are going to depend on the manual procedures. So whereas here in the modern iterative process, they are going to use mostly they are going to use the automated. So it is very error-free evaluation of the artifacts. 70% of the automations are mainly used in the modern iterative process. And next one is resource adequacy. So the resources which are required by the team members is unpredictable in the conventional process, whereas in the modern iterative it is predictable. So initially they are going to identify the what are the requirements required for the team members. And schedules. So this can be over constrained, and this can be tunable to the quality, performance, and the technology. So based upon the quality and the performance, these schedules will be tuned accordingly. And target performance. So this conventional process is mainly based upon the paper-based analysis, or will be used the separate simulations. Whereas in the modern iterative process, they are using the executive prototypes and early performance feedback, quantitative understanding. So these are the main. It will be used in the modern iterative process for the improving the performance. And next one is software process rigor. So it is mainly having the document based, whereas the modern iterative, they are going to use the managed measures and the tool support. So these are the main metrics which will be improving the quality of the software. So what are the key practices overall to improve the software quality means? Mainly they need to focus on the driving requirements and checking the critical use cases in the early stages of the life cycle. So when they're focusing on the requirements, so it will be, I mean, after the life cycle, so it is very huddle to the unchangeable or unpredictable of the software quality improvement here. So that's why in the initial stage only they are going to identify the what are the requirements and what are the bugs in the early stages of the life cycle. Next one is they need to use the metrics and the indicators to measure the progress and the quality of a architecture. So when they're using these metrics and the indicators, so it will be the quality can be easily improved with the help of the high level prototype. And okay, and next one is integrated life cycle environments. So they can have LALA and continuous configuration control, change management, rigorous design methods, document automations, and regression test automations. So this can be how can be used for improving the software quality, and also we can have the visual modeling and higher level languages. It will be support the architecture control abstractions and reliable programming. Reuse concepts and the self documentation is very important to improving the software quality. And also we need to check some performance issues. So what are the performance issues? Means mainly runtime performance issues will be very important here while you are running the project here, and they need to verify about the commercial components and the custom developed components are very important for the checking the runtime performance issues. So whereas in the conventional development process, stressed LLA sizing and timing estimates of computer program resources utilization. It means they need to check that what are the mainly to improve the performance. The first one is project inception. So this is the starting stage where they're going to design the architecture, and it will be very low risk and having the performance margin here. And whereas in the initial design review, so they need to verify about the adequate design margin, and also mainly paper analysis has to be done, and or they need to go the simulation of the critical threads here. Okay, and next one is they need to maintain the algorithms and the database sizes very fairly, and also have the infrastructures. Okay, so that it should not be how the operating system overhead and database management overhead and interprocess and network communication overhead. So it should be very smoothly to handle for understanding of the quality improvement of the performance here. And also they should not be misunderstood when they're using the threads. Okay, and next one is midlife cycle design review. So here mainly they are going to verify about the benchmarks and initial test, and having the inherited in the LA estimates. Okay, integration and test. So this is very serious performance problem. Why means they need to verify about the uncovered and necessitating fundamental changes in the architecture. So it will be very having the issues while they're going to check in the integration and the testing part here. And also having if it is having the infrastructure is immature and architecture solutions are immature, and if you're not understanding the design uh, not properly, then it will be very difficulty for designing the quality of the software. So what we need to do means we need to check that the various constraints to improve the performance in the software. And also here the large scale distributed system, so mainly it will be demonstrate based approach, and also have more accurate assessment of the performance issues while we are designing the large scale distributed system here. And mainly the target is host or target platforms or partial networks configuration we need to demonstrate. Okay, and also here the planned and managed, so it will be provide the fruitful engineering exercise. So really we need to check that what are the performance issues are getting, and to gain the healthy, mainly we need to identify the what are the faults in the architecture and weaknesses in the commercial components, and what are the trade-offs, and we need to verify in the early stages to build the more quality of the software here. Okay, So here I have referred this, this website and the textbook I have referred. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.